A column for each of the 9 solutions will be made in the microplate. Be sure to pay close attention to each location of the solutions. Then, one at a time, each solution will be mixed with each of the others and observed for a reaction or formation of a precipitate. Data will be recorded, and the goal of this lab is to do as few combinations as possible. Using observations from the lab and the prepared data table of expected results, each unknown will be matched with its identity. This will be done by comparing frequency and color of precipitates and the production of gas for each solution. For this lab, a labeled microplate with 9 unknown numbered solutions will be needed, along with a spare microplate to undergo tests, a lab notebook to record data, and a table with the results of different combinations of known solutions to compare laboratory results with. The first thing we noticed about the solutions was that 2 were blue, meaning they contained copper ions. We chose solution 1 and mixed it with the remaining non-copper solutions. When mixed with solution 9, a blue precipitate formed. These solutions are sodium iodine and potassium carbonate, respectively. Since solution 1 only reacted with 2 other solutions, it is copper 2 nitrate.
Next, we mix the potassium carbonate with solutions 2, 3, 4, 5, and 7. It did not react with solutions 5 and 7, formed white precipitates with solutions 2 and 3, and created bubbles with solution 4, which we determined to be hydrochloric acid. We knew that 2 and 3 had to be barium chloride and lead 2 nitrate.
Therefore, we chose solution 2 and mixed it with solution 6, sodium iodide. Since there was no reaction, we knew that solution 2 was barium chloride and solution 3 was lead 2 nitrate.
The only 2 solutions remaining were sodium chloride and sodium sulfate, 5 and 7. We chose 7 and mixed it with barium chloride, solution 2. Since it reacted, solution 7 was sodium sulfate and solution 5 was sodium chloride. Once all of the identities of the solutions have been determined, the only analysis that must be performed is the writing of net ionic equations for each of the reactions that occurred during our experiment. A net ionic equation leaves out the substances which remain in solution and do not participate in the reaction, called spectator ions. The net ionic equation of barium chloride and sodium sulfate, for example, is Ba2 plus Aq plus SO4 2 minus Aq yields BaSO4 solid. Na plus and Cl minus are spectator ions.